Welcome to Basic Brewing Radio for Thursday, October 11th, 2007. I'm James Spencer. Here at Basic Brewing Radio, we're all about home brewing. Well, this week, chemistry professor Bradley Sturgeon joins us to give us basic instruction on how to use some fairly essential tools in brewing: the thermometer, the hydrometer, and the refractometer. Have you been using yours correctly? Have a listen and see. If you're new to home brewing or would like to get into the hobby for the first time, check out our website, basicbrewing.com, where you can find archives of our audio and video podcasts and our DVDs to walk you through basic and more advanced brewing techniques. I want to do a quick jump into the mailbag before we get into our topic for today. I got some interesting comments after our offbeat yeast episodes with Michael Tonsmeyer and our Brewing with Bread Yeast video episode. Dr. Trevor from Edinburgh, UK, writes, I brewed an all-grain German Hefeweizen and reserved a liter of wort before pitching the yeast. To this liter, I added a teaspoon of San Francisco sourdough starter. The starter, he says, is a flour-water mix in which you keep the yeast alive when you're not baking with it. A month later, Trevor says, after fermentation was complete and I'd bottled the beer, I was quite surprised that it tasted great. It was very dry, much more so than the Hefe, and only slightly tart with a complex fruity taste. I think I preferred it to the Weizen and regretted not doing a full-sized batch. Dr. Trevor says, I'm not sure what critters live in the sourdough, but I do know that there are many strains of Saccharomyces, Lactobacillus, and a number of wild yeasts. I plan to do another batch where I age it longer, 6 months to a year, to see if the sourness develops further. Well, that sounds like fun. Damon from Highlands Ranch, Colorado writes, I just saw the brewer's yeast in bread and bread yeast in beer experiment, and I am inspired. I was thinking on how to recycle my yeast after I grow into the secondary, and now, because of you, I'm going to make bread. That way, all I have to do is buy the good yeast for the beer, rack off, and then make bread. This will save money. Not much, but it is fun this way. So that's what it's all about. It's not all about money. It's about having fun, too. And Per Eric from Stockholm, Sweden writes, I just saw your episode about exchanging yeasts. I would like to share my experiences in that matter. The baking yeast that we usually use in Sweden is not a dry yeast. It's more like a dough. It's very potent, and when you use it for beer brewing, you should really have small amounts, or you should have really small amounts. The downside is that it will ferment to a really low final gravity, making the beer taste more like bad dry mead or crappy wine. The only way to make it drinkable is to add some sugar just before you drink it to get the yeast active again, or as you did, have lots of hops in it. It will give a lot of banana esters. And Per Eric says, one traditional Swedish beer type is Gotlandstricka. I hope I'm pronouncing that somewhere close to in the ballpark and not swearing accidentally. Gotlandstricka, where you use baking yeast and have lots of smoked malts and really small amounts of hops. It's not comparable to a normal beer. It tastes quite bad, actually, but a tradition is always a tradition. So, it tastes quite bad, actually, but a tradition is always a tradition. That should be my slogan for some of my beers. Kevin from Everett, Washington, and Ben from Lawrenceville, Georgia, both wrote in on the topic of using rainwater in brewing, and both pretty much had the same point. They essentially agreed that rainwater is similar to distilled water. However, both Kevin and Ben caution that rainwater might pick up pollutants on the way down to the ground, falling through potentially nasty air. So if you live in an area with bad air, take that into account when considering brewing with rainwater. It's a good point, it's too bad we have to worry about that. That's just a taste of the mailbag this week. I appreciate all the email. I'll try to make more time next week for more letters. Over the years, several of you have written asking for a show about today's topic, thermometers, hydrometers, and refractometers. I called upon Brad Sturgeon, assistant professor of chemistry at Monmouth College in Monmouth, Illinois, to give us the lowdown. Well, Brad Sturgeon, welcome back to Basic Brewing Radio.
Thanks, James. It's great to be here.
Now, I really appreciate your being on the show, and I appreciate your having credentials as someone who, actually instructs people, because what we're going to talk about today is something fairly basic and scientific, in talking about these three tools. But I think if you really want to do your brewing right, if you really want to pay attention to what you're doing, it's essential that you know how to use these tools, right?
Yes, I do agree. Yeah.
Well, let's start off with the most basic one, and the one that everybody has to have pretty much to do brewing, and that is thermometers. What types of thermometers are out there? And when we're brewing, what are we looking for?
Yeah, okay. Well, as a physical chemist, we refer to this as thermometry, make it sound a little fancier than it really is. But I give you a lot of credit for, first off, being aware of the different scales. So we have Fahrenheit and Celsius that our overseas colleagues use, and most of us use that in the scientific field as well. But then there's also Kelvin, which is one that you may see on some occasions. We haven't had to get into that just yet, but.
And if you get your wort down to 0 degrees Kelvin, you're in trouble, right?
Yeah. Well, either that or you'll get a Nobel Prize. I'm not sure.
0 degrees Kelvin is the point where everything basically, that's as cold as you can get, right?
Well, if you get there, then all motion stops, and then the relativistic theory of sizes and masses take over. And so we're not sure what will happen if you actually got there. So let's stay about 0.1, 0.2 Kelvin above that, and we won't ever have to worry. So,
well, there you go.
So anyway, the different types of thermometers. Essentially, there's three kinds of thermometers. The first one is what we call, in technical terms, a liquid-filled glass. So I think we're all familiar with the mercury thermometers. Those, of course, mercury is a toxic substance, so we try to remove those, and even in the chemistry lab here, we have removed those in favor of alcohol-filled glass, which comes in like a red or green dye color so that you can actually see that level. Those are pretty good, pretty reliable thermometers. But most of us, I think, in the brewing have switched over to sort of electronic devices. The first one is a thermocouple, which essentially has two different wires connected together, and as a result of that junction between those two wires, you can measure a voltage which is proportional to the temperature. So making that voltage measurement with some sort of little digital device, then you can get temperature. Unfortunately, with the thermocouples, you usually have to have a reference temperature to get accurate readings. So, but the third one is called a thermistor, and these are real good names here. They kind of say what they do, and a thermistor has a resistor in there that's dependent on temperature. And so those are, I think, probably much more common in some of the sort of like cooking store thermometers that you would buy, the digital type ones.
So if I go to my local restaurant supply store and get a little digital thermometer with a probe for sticking in meat or something like that, that's the kind that's going to be?
Yeah, the thermistor. And again, they don't tell you necessarily on the package, but I'm guessing it's probably most likely a thermistor, yeah. That's a pretty straightforward way of measuring resistance and then relating that back to temperature. And, the nice thing about these electronic devices is that the resistance versus temperature relationship can be stored in the memory of the little electronic device, and so typically you don't really have to calibrate those. On occasion, you want to make sure that they're working properly, and I've had some of those meat-type thermometers go bad, and I just end up chucking them. So.
Now, what about the long probe, non-electrical thermometers with a little dial on the end of them? You can get, I've got some little meat thermometers that have the same theory. It's a long metal probe, and then you stick it in the meat, and then it's got a little analog dial at the end of it that spins up to the proper temperature.
That's right. Yeah, there are some metals that are sensitive to temperature. And so I think in some of those, if you look at inside the head of that thermometer, as you put the spiky part inside of something, a liquid or whatever, that will transmit the heat up to a small piece of wire, and that wire will change shape slightly, and then that's what makes the meter rotate. So those are fairly dependable, although they're, if you don't treat them right, they can kind of get bent out of whack, and they may not be reading the temperature. So you may want to check those more frequently against some calibration standards.
Now, with the glass thermometers, there is one safety tip that I'd like to pass on, and I discovered this myself, that I had one of those floating thermometers, they're enclosed in the little glass tube, and I discovered that if you drop them into the wort after you've taken the temperature and they hit bottom, they'll break.
Uh-huh.
And then you've got a food safety problem, and if you're a conscientious brewer, you throw away that wort because it's got broken glass in the bottom of it. So be careful with things like that.
Well, and I would guess that also in those type of thermometers have some sort of heavier metal that is kind of make sure it stays underground there under the solution. So I don't know what that metal is. It could be some sort of alloy that we may not want to be partaking in.
So that's our first safety tip of the night there. Be careful.
There you go.
Be careful
Excellent.
with the glass. So how do we tell on the thermometers that we can calibrate? How do we tell that they're working properly? Yeah,
well, really what you're looking for is some calibration standards. And again, I'm glad you pointed out the way you did, because a lot of times we use the term calibration, but really if you're calibrating it, that means that you're sort of making a measurement and then making, like a scribe on the piece of glass that says this is a certain temperature. Really, for the most part, we're just checking whether they are calibrated or not. So there's two temperatures that are pretty readily available, and the first one is just ice in a water bath. The temperature of that is about 0.01 degrees Celsius. So, among friends, it's essentially 0 degrees Celsius. One of the keys in doing that, though, is that you want to make sure that your ice bath is well stirred, because the ice will float on the top, and you will get a temperature gradient over, the depth of the liquid. And a lot of times, especially if you're using some sort of long thermometer, you might just have it hanging or sitting at the bottom of the solution or this ice bath. So you want to make sure that you're stirring it real good to keep a consistent temperature when you're checking for that 0 degrees mark there.
So I've heard it said like a 50-50 solution of ice and water, kind of a, really kind of slushy, and maybe more heavy on the ice side would be more safe?
Yeah, most certainly. And one of the things to stay away from is make sure that the glassware, whatever you're using, is clean, because if you have some residual stuff, not that you would find yourself with, say, table salt in there, but table salt will actually depress the freezing point of water. So you want to make sure that that's not that it's a very clean. In my technical books, they say to use distilled water. And I've never been so geeky enough to actually make ice cubes out of distilled water for this reason. But, you've talked a lot about on your show about the water quality. And so it's always possible that if you have really hard water, you have suspended material in there. And that could affect the temperature, but probably not by a terribly large amount. So.
Salt water being able to be colder is the reason why you use rock salt when you're making ice cream.
Yeah, we love doing that in the lab. That's a great. That's wonderful. That's what we call colligative properties. So, yes.
So now we've got the lower end to calibrate there with the freezing point. And one would assume that the other end is?
The boiling, yeah. That's exactly right. Man, it's like we got this down, James. Yeah, so the other point is boiling water. And boiling water is essentially at 100 degrees Celsius. But you must be aware of what your atmospheric pressure is. For instance, if you live in Denver, the atmospheric pressure is lower in Denver. So from a chemistry standpoint, you can think of it that there's less air sitting on top of your head or less air sitting on top of your bucket of water. And when there's less air pushing down on that water, it's easier for it to boil, so it boils at a slightly lower temperature. So, the atmospheric pressure changes on a daily basis, but generally in Denver, water may boil at some 95 degrees Celsius or 203 Fahrenheit. So that could be a significant, difference in your checking your conversion. You're either at 152 or maybe 147. That could make a difference in the way things come out.
Now, I know that on those analog probe thermometers that I was talking about, maybe some of them at least, maybe if not most of them, have a little nut on the opposite end of the, if you turn the thing around and look at the probe side of that radial dial there, you'll see a little nut, and that's actually an adjustment nut, so that if you put the end of your probe into your solution of 50-50 ice and water, and it doesn't read 32 degrees Fahrenheit or 0 degrees Celsius, you can just take a little wrench and adjust that little nut on the back of that thing, and that's the way to do that.
Yeah, well, and I haven't used one of those in quite a while. I know what you're talking about, but one of the things I guess you could be sort of a practice that if you adjusted it when it's in ice water and then you decide to move it over into then the boiling water and then adjust it again once you get into the boiling water, that would sort of a single nut calibration is pretty much sort of a rough estimate to get it in line, because you really need to have 2 points in order to determine the linear range of a thermometer. So, but yeah, having that adjustment is a good one. And again, you could adjust it probably on the high side opposed to on the low side, since we're usually measuring temperatures up in the hotter range more than in the colder range. That's
true. We're looking at more mash temperatures and checking to see how close we are to boiling usually when we're taking temperatures. So
right.
So that's a good point. I have run into a couple of frustrating situations where I've checked the temperature of my mash with 2 different thermometers and gotten 2 different readings. So so it is important to get your stuff, to know where you are, because if you're depending on one thermometer and your thermometer's wrong, then you're not doing yourself any good. On the other hand, if you brew your beers well and you always rely on the one thermometer and it's wrong, but you're getting good results, as long as you still rely on that same thermometer,
yep, that's right.
It all depends on what your measuring stick is.
That's right. Yeah, well, and consistency is a big thing, and yeah, that's a good point to keep in mind for sure.
Now, before we leave thermometers, are there any other tips or tricks that you would counsel us on the proper way to take a temperature?
I see a lot of times if you have a thermometer that will actually sit on the bottom of a kettle or something like that, then a lot of times the surface of the kettle, especially if it's on the bottom surface of the kettle, may be significantly hotter than actually the liquid. So, having some sort of support so that a thermometer could be placed in the middle or away from the edges so you're actually measuring the solution, is probably the only piece of advice. But, in a perfect world, we do not live. And even if you had say, put 4 or 5 thermometers in a boiling system, you may find a temperature gradient across that system, or across a certain size of a kettle. That's why we always push for a good rolling boil to make sure everything's moving around good.
Or if you have one of those long probe thermometers and you've got a mash going, and if you check in different parts of the mash, you can find different temperatures. So there may be pockets of higher temperatures or pockets of lower temperatures.
That's exactly right.
I don't know if this is proper technique or not, or if it's just superstition, but whenever I'm testing the temperature of my wort, I stir it up first. And I don't know if that's doing me any good or not, but that's one thing that I do as well.
Yeah, well, it definitely can't hurt as long as you're not stirring with a liquid-filled glass mercury thermometer.
Who would do that?
Yeah.
Now, our next tool is not technically necessary for brewing, but it sure is handy if you are wondering where you are in your fermentation process, and that's a hydrometer. Now,
that's right.
What is a hydrometer? What does it measure, and how does it work?
Yeah, well, in a technical sense, all a hydrometer is measuring is the density of the particular solution that it's floating in. And the density is actually related to the dissolved solids. Now, I do some work here with soft drinks, and typically in using a soft drink, the majority of the dissolved solids are these sugars. And the same thing goes for in brewing, that the majority of the dissolved solids are sugars, although we also know that there are proteins and there's other sorts of things that are dissolved. So really, a hydrometer is measuring the density of that solution. We say that the sugars that are going to ferment are the major component of that. So we pretty much just talk about hygrometers as measuring, a term called specific gravity, but we relate that to the concentration of sugars and then hence the alcohol that it could produce.
So we are measuring, when you're looking at the scale on the hydrometer, 1.0 would be the density of water?
Actually, yeah, it's the specific gravity, which specific gravity is essentially the density of the solution that you're floating in relative to water.
Okay.
Yeah, and one of the biggest technical points on a hydrometer is that oftentimes temperature plays a real key role in here. And one of the things that we don't see very frequently, but the volume of a solution is actually dependent on its temperature. So the hotter the solution is, the larger its volume. And if we're indirectly measuring, or with this hydrometer, we're measuring density. Density is defined as the mass per volume. And so if you have a solution now that's a little bit hotter, its volume's a little bit bigger, but its mass is still the same. So its density is a function of temperature. So on your hydrometer, it'll tell you sort of what temperature to be at when making your measurement. And if you're not at that temperature, there's a correction factor that you need to use. I
guess we should say for those novices who, because we have people listening from all different skill sets, the hydrometer is essentially a bobber with a scale on it that you sink it into a cylinder of liquid, and then you read the where the liquid touches the little meter on the side of it. That's where you measure your specific gravity. And what I like to think of is when the solution is warmer, the little bobber can sink lower, right?
Oh, let's see. If it sinks lower, that's right.
So you'll get a lower specific gravity reading if your fluid is warmer.
That's right, because the solution that you're measuring has, when it's warmer, it has a larger volume than it should. When it has a larger volume than it should, then its density is lower than what it actually would be if it was at the proper temperature. So the bottom line is that the temperature is critical when you're taking a hydrometer reading. Certainly is, yes. That's right.
Now, and you should look at the instructions that come with your hydrometer, because mine is calibrated to 60 degrees, But others, I believe, are calibrated at 68 degrees, and those temperatures are Fahrenheit. So it's important that you look at the temperature that your particular hydrometer is calibrated to. And then in the instructions that came with my hydrometer, there's a little correction chart in there to kind of help you get a ballpark of what kind of corrections that you need to make per the temperature of your fluid.
That's right. Yeah, and mine, I have actually made a copy of mine here. Yeah, it's also 60 degrees Fahrenheit and is sort of a beer/wine hydrometer. I got really excited one time when I found this box of hydrometers here in the chemistry lab, but I realized that there's all different ways of calibrating them. So, for instance, there are hydrometers that are used for measuring the salinity of water, and that's in a different range than if you were going to be measuring, say, the specific gravity of a beer or wine. So I thought I'd run into a gold mine, but it turns out they weren't very useful for brewing purposes. So.
You could be mean and give them out anyway.
Well, there you go. They look nice. I could just put them up on a rack, and they're pretty.
Now, I was talking about how to read the hydrometer, but there is a trick to actually picking the point where the fluid meets the scale, right? And that's generally, the solution for water in a restricted sort of neck vessel or something like that will have a sort of this concave look to it. And generally, we like to make measurements at the bottom of that concave. But, the hydrometers on occasion have a tendency to kind of lean to the right or lean to the left. I have a tendency to try to knock it so that it kind of stands up in the middle. There is some inherent error in reading the hydrometer if you're looking down on it, or if you're looking up on it, or if you're looking straight at it, you'll get a slightly different reading. So I think that's an inherent, sort of accuracy of reading of a hydrometer that there is some variability there. So we do the best we can. And I tend to spin the little bobber thing, the hydrometer, to get any bubbles that are hanging on. I don't know if I'm making stuff up or not, but in my imagination, if there's bubbles hanging on to it, those are helping to push it up a little bit. So.
Yeah, well, and I did a little bit of work in a brewery where we would take samples off of the fermenting vessels and measure their gravity to sort of see a fermentation profile, and we would always rock those solutions back and forth into two large beakers to make sure that we decarbonated it before making the measurement, because, as you say, you put a piece of glass in there, you will start to have bubbles form around the outside of the glass, and a good stiff spin without knocking over your graduated cylinder or something, which happens, is a good way to prevent those bubbles from actually holding the hydrometer, up in that solution there. So,
and I guess we should say that there are computer programs. If you've got, say, a ProMash or some of the beer tools or Beer Alchemy, I'm sure that there is a hydrometer temperature correction feature in there that you can, feed in what your temperature of the solution is, and then what your specific gravity reading is, and then it will figure out what your accurate specific gravity is. And there are also websites out there that have those little things right on the website. So if you don't have the computer programs, look for hydrometer temperature correction, and surely you can find something out there.
That's right. Yeah, and one of the other things that you had written me in a note here also was that there are the hydrometers that actually have a built-in thermometer, which is very nice because you can make your measurement, pull out your hydrometer, read the temperature, and then right across from it has a correction factor on there. So those are kind of a nice model to have, opposed to the one that you have to measure the temperature separately. But these, as far as calibration of hydrometers, there's not a whole lot you can do about it. At least in mine, that little piece of paper that's kind of embedded in there is kind of fastened in there in one place, and I assume as they get old that might slide left or right or up or down, excuse me. So there's not much you can do when your hydrometer starts to kind of go out of calibration. But
to check your hydrometer, can you take a measurement of distilled water?
Yeah, you can use distilled water. That should definitely give you a reading of 1. And again, make sure that you're at the proper temperature when you're doing that, and that should let you know whether your hygrometer is functioning properly. Again, so this is kind of the concept of checking opposed to actually calibrating that hydrometer. So.
And another safety tip: if you happen to drop your hydrometer on the kitchen floor and it's tile. The dustbuster won't pick up those little round thingies that are in the bottom of the thing to weight it down.
That's not a good sign there. You're talking about some heavy element, I'm afraid.
Oh, great.
That's all right.
That's why my fingers tingle.
There's no peeling of the skin on the tips of your fingers, is there?
No.
Okay, good. All right.
This happened a while ago, so yeah, I was I was getting the dustbuster out because I broke my hydrometer, and there were all these little bitty BBs everywhere, and I took the dustbuster and it got the glass okay, but it didn't pick up those heavy things, and I had to actually physically sweep those up.
Huh. Well, you probably needed a new one anyway with all that brewing you're doing.
Let's move on to happier things and refractometers. The fancy thing. One of my Christmas presents last year, I think, a refractometer. What is that? How does that work?
Yeah. Well, that's a wonderful little device. It's been around in the science community for a long time. Essentially, a refractometer takes advantage of the fact that when light passes from one substance to another substance, the light will bend. And this kind of phenomena we see a lot of times if you're, say, looking in a fish pond over the railing or something, you see a fish. That fish is really not in that particular location, but it's actually a little closer to you because the light is coming in and bending. So the angle that the light bends can be used to determine the concentration of dissolved solids in a particular solution. So just like the hydrometer is measuring density of the dissolved solids, a refractometer also can be calibrated to measure dissolved solids based on what we call the refractive index. So these are, with yours, and I don't own one of these handheld ones because I have one in the lab, but what are the units on your handheld refractometer?
Mine is in bricks.
It is in bricks, okay. All right. Yeah, that seems to be the traditional unit, which a brick is essentially a Plato, or degrees bricks, or is a degree Plato. It turns out there's just a small difference as far as a bricks is calibrated at 20 degrees Celsius and a Plato is at 17.5. So really to adjust between the two of them, it's almost like doing a small temperature correction. As you've noted with a refractometer, they're very nice to use. You take essentially a single drop and put it onto a glass prism of some sort and close the lid and put it up to the light. Is that how you do it?
Yeah, and then you can see the little scale in there, and it lines up there to tell you how many bricks your wort is. And one handy way, may not be the most accurate way, but one handy way to change bricks to specific gravity is to multiply by 4. So if you have 10 bricks, that's approximately 1040 on the specific gravity scale.
Oh, okay. Okay.
And there's an application that I use online that will also convert bricks to specific gravity. So that's another thing that you've got to rely on the computer for to get accurate readings for your brewer's notebook.
That's right. And I've had some good luck with sites like Wikipedia. as far as their description about bricks and Play-Doh, and actually the older scale called a balling. They have some pretty simple equations in there that you can make that conversion if you need to. But I mean, do you bother to shift between bricks and Play-Doh? Do a conversion between those in making the measurement?
Not between bricks and Play-Doh, but I do go between bricks and specific gravity. Because
Okay.
I've brewed for however many years, knowing what specific gravity means, and then
Right.
all of a sudden, I'm switching. I'm learning, but it's kind of like probably going from Fahrenheit to Celsius. My brain is still lining up as far as what the expectations are. If I look in my little viewfinder and see 14 bricks, I've got to say, is that good or bad?
Yeah.
But the advantage that the reason that I like the refractometer is that if you're out by the brew pot and you're bringing your wort up to boil and you want to know what your pre-boil gravity is, if you're using a hydrometer, you had to take the sample out and let it sit for a while to get it, fairly close to the range that the hydrometer was calibrated to, I guess you'd say.
Right.
Whereas with the refractometer, what I do is I just take a little spoonful of wort and set it aside and let it cool down a little bit, which doesn't take long at all, and then just put a couple of drops on the hydrometer or the refractometer and shut the lid and look up to the light, and there you go.
And drink the rest off your spoon, right? Yeah.
Well, sure, it'd be good to taste it, but it's unfermented at that point, so it's not as fun. But also with small batch brewing, if you're only brewing 3 quarts, or 3 liters, a hydrometer sample is a pretty good chunk of that. So with a refractometer, you don't have to take a big sample and risk, returning it back to the fermenter if you want to, if you don't want to waste it.
Right. Well, and that's right. And it's such a temptation when you're doing small batch brewing to not waste any of it. And so people may have a tendency to pour it back without maybe not properly sterilizing, or sanitizing. I'm sorry. I should have learned that from all of your great insights.
And if your hydrometer tube is as nasty as mine is, then
yes.
I mean, I clean
That's
it,
right.
but I've never sanitized it. So how would you calibrate your refractometer? Because there is a calibration knob on the refractometer.
Yeah. Well, and the best way to do it again is to use deionized water. You can set it to a 0 reading. Again, there is a temperature dependence on the refractive index. I'm not quite sure if it's more or less sensitive than the density, but does yours say that it's specifically at 20 degrees Celsius?
Now, the instructions, I don't know if I ever read the instructions, frankly, but I think the theory behind the using, one of the reasons why the refractometer is so easy to use is that the sample is so small that by the time it's spread out on the lens, it's pretty much at room temperature
Right.
or outside temperature, whatever the ambient temperature is. So I need to go and check that for sure to see what the rules are officially.
Right, and actually I have from one of these textbooks there's an appendix for temperature correction for refractive bricks readings. And so if you're at, say, 25 degrees instead of, say, 20 degrees, you're talking about a correction of like 0.3 bricks. So even if you're at 30 degrees Celsius instead of 20 degrees Celsius, the correction is 0.77 bricks. So yeah, as I look at this here, it appears as though that the refractive index is not as sensitive to temperature as a density measurement might.
And we're home brewers, so
That's right. Yeah.
We're just looking for, I'm just looking for a ballpark anyway, so.
That's right.
But
yeah. Well, my students today and I got together in our physical chemistry lab and decided to investigate some of these measurements. We made up a series of sucrose solutions and measured their specific gravity with a hydrometer, and then also measured their percent bricks using this refractometer that we have. And there was a couple of interesting things that we found. One of them, and these students have not used a hydrometer or a refractometer until today. And if you look at the accuracy of the measurement with the hydrometer, there's inherently a lot more sort of human error in those measurements versus the refractometer. And again, you know how easy it is to use. You put it in there and look through there and line up the line.
Mm-hmm.
As you had mentioned before with the hydrometer, you kind of got to be worried about the meniscus. You got to be worried about bubbles, whether it's leaning to the left or leaning to the right. So again, one of the benefits of a refractometer is that there's a much greater consistency between, person A and person B in making that measurement.
Now let me ask, this is pure coincidence that you guys were studying this topic on the day that we...
Well, it's we like to bring science into the realm of sort of real world, and I pretty much told my students I was talking with you tonight, and I asked them if they would be willing to partake in some activities, and they were good to go, and I thank them for that. So.
Well, we thank them as well, and in this day and age of fuels, like ethanol and other fuels that will come from the fermentation process, it's probably a pretty good skill to pick up, learning about the refractometer and the hydrometer.
That's right. Oh, no doubt. I mean, biofuels here in the Midwest is a big deal. We have lots of corn and the cellulosic ethanol production. A lot of people thinking about those things in our area. But, hey, let me just contrast a little bit of this data that we talked about today. And one of the things that we did in the design of the experiment is we started off with a certain concentration of sugar that might have been equivalent to something like a 1057 specific gravity. That's somewhere around 14 bricks. The solutions that we made as we decreased the concentration of sugar, we did a calculation which said that if that sugar decrease was actually converted into ethanol, then that ethanol would then be added to that sugar standard. So let's say, for instance, the sugar standard at, say, 10 grams of sugar instead of 14 grams, or the 14 bricks or 10 bricks, those 4 grams we pretended like they were converted into ethanol. And so when we made these measurements, it was kind of interesting because once we got down to a standard that had no sugar left in it, we had a lot more ethanol, of course. And ethanol, the density of ethanol is significantly less than 1. So our hydrometer reading was actually like 0.99, something significantly lower than if we had no ethanol in there.
Mm-hmm.
When you make that same comparison on the refractometer is not making measurements based on density, but it's making measurements based on the refractive index. And therefore, at 0 sugar, and all that sugar has been converted into ethanol, now the refractive index measurement is reading something like 3 bricks because we're associating the refractive index with the ethanol to the sugar that was there. So we have to be very careful about using hydrometers and refractometers because they appear to give you sort of different results. And I think some of your viewers have tried to address this in the past.
Yeah, we have typically said that refractometers are good before the fermentation process, but after the fermentation process starts, the amount of alcohol in the solution starts to skew the readings of the refractometer. And this experiment pretty much proves that out, right?
That's right, and you can feel free to post those graphs that I sent you, which show this. And again, the graphs themselves probably need a little explanation as far as the standard containing a certain amount of ethanol based on how much sugar had been consumed, and it may cause more problems than good. You never know.
Now you referred to one of our listeners helping out in this area, and Will from Portland, Oregon, way back in August, sent me a formula and then an Excel spreadsheet based on the formula. And I haven't played with it too much, to tell you the truth, but what I'll do is I'll post Will's Excel spreadsheet on the website so that listeners can download the spreadsheet and play with it themselves. But this will help to do the corrections if you're trying to use a refractometer in a post-fermentation environment. And if you look in the description of this episode on basicbrewingradio.com, then I will post that there. And thanks very much to Will from Portland, Oregon, and I promise that I will play with the spreadsheet. I just hadn't gotten to it yet. It's only been, a couple of months. But did you get a chance to look at the spreadsheet, or did you get a chance to look at the formula? Is pretty darn complex.
Yeah, it is, and I guess when I see those kinds of formulas, I saw a lot of units that were squared and then raised to the cubic to the third. There seem to be a lot of numbers in there. Oftentimes, as a scientist, when I look at an equation like that, I look for physical meaning to have, those 6 different parameters as part of that function. And so, I could get caught up in spending a lot of time with that equation, which I did not spend a huge amount of time, although I did look through it. So.
And I must give credit to Louis Bonham, who will he cites from a January-February 2001 Zymergy article,
right,
talking about how to compensate for alcohol. So hopefully useful stuff.
That's right.
But I guess that I'm just going to be one thing that the hydrometer has over the refractometer when you're measuring in a post-fermentation environment is that you can take the fluid that is in your hydrometer tube and drink it. So I don't know that I don't know that I'm going to, even if I knew how to convert the refractometer readings into proper specific gravity, I don't know that you're going to get me away from my hydrometer.
Well, that sounds good. Hey, James, I maybe had jumped into that data because I was excited to share that with you, but we were talking about some calibration aspects of the refractometer, and DI water, of course, will calibrate at a 0 Brix reading. But one of the things I have not tried, which you probably could try, you could take your favorite soft drink, you decarbonate it, and generally something like a cola will have like 39 grams of sugar in that bottle or can. So you have to do a little bit of a unit conversion, but you could mix 50-50 with distilled water and get a concentration of sugar that may be in the range of, sort of like a 1050 wort. And you could use that as a standard, assuming that the label on the soft drink is good, which I'm pretty certain it is, because when they're making that much soda, if they're too high or too low, it's a big deal for them. So. Well,
Brad, I really appreciate your time.
It's my pleasure. It's great, James. I always love being part of your program and having you here in my home listening to it, too.
Well, excellent. We've had requests for shows talking about how to use these things and how to calibrate them and what to expect from them. And it's long overdue, and I'm glad that I had a knowledgeable person to help me out.
Well, I'm more than happy to help out.
Thanks, Brad.
All right. Thanks, James.
Well, thanks again to Brad Sturgeon. I hope to do more science-related shows in the future. And I'll put links to the documents we talked about in the description of this episode on basicbrewingradio.com. If you have brewing questions, show suggestions, or just want to say howdy, write to james@basicbrewing.com, or just fill out the contact form on basicbrewing.com, and please don't forget to tell us where you're from. And while you're on our site, you can check out our online shop, where you can find great pricing on our DVDs and a combo deal to save you even more. In our first DVD, Basic Brewing Introduction to Extract Home Brewing, we walk you through the extract brewing process step by step from boiling to bottling. And in Basic Brewing Stepping into All Grain, we take you through the all grain process from milling your grain to collecting your wort. In our third DVD, High-Tech, or Low-Tech rather, change the title right there. Low-Tech lagering and decoction mashing is on the way. So keep your eyes out for that. Should be in just a few weeks. You can see a listing of the fine folks across the country who sell our DVDs on basicbrewing.com. And if there isn't a vendor in your area, you can order it from us online, and I'll pack it up myself. And we've also got shirts and hats. And also thanks to everybody who's continued to click on our Amazon.com link. We appreciate the support there as well. Our featured products this week that were purchased through the link are Weekend Refinisher and Yamaha French horn string. I didn't know French horns had string, but there you go. I've been playing it wrong all these years. No. Thanks again, everybody. Remember, I can't tell you who bought what, so no worries there. Just click on the Amazon.com logo on our site the next time you feel like Amazon shopping, and we appreciate your support. Well, that's all until next week. Until then, thanks for listening, everybody. I'm James Spencer. Production help for Basic Brewing Radio and our website is provided by our buddy Kelly Dodson down there in Austin. He also did our logo. Basic Brewing Radio is a production of Active Voicing. We'll talk to you next time, everybody. So long.